Linux file systems. In this nugget, we're going to explore file systems in Linux. We'll talk about the different types of file systems that are out there and what they're used for. We'll also talk about how to create file systems, how to repair them, how to mount and unmount them from your system, and we'll wrap up by looking at some important file system related configuration files. So let's get down to it. Well, let's start with a little overview of file systems and Linux file systems in particular. So what is a file system? Well, a file system helps organize files on disk. So when you go to save a file or retrieve a file from a hard drive, for instance, the file system is what's responsible for navigating through the disk and getting the actual data of the file into memory so that you can operate on it. Now, the file system that's used depends upon the media, like whether it's a hard drive or a CD-ROM, and also the operating system as well as some other things. And common file systems that you'll see in Linux are ext2 and ext3 are probably the two most common ones. If you can guess here, ext3 is an extension of the ext2 file system. It just has a little bit more functionality in it. The swap file system is what's used for swap space on a hard drive. ISO 9660 is the file system used on CD-ROMs. VFAT is a 32-bit Microsoft Windows file system, and the only reason you would see that on Linux is for some sort of cross-platform sharing between Linux and Windows. And then there's the Riser file system, which is a newer file system developed by DARPA, the Department of Advanced Research Projects. And this file system is the base file system in some Linux distributions. So now let's talk about how to make a file system and the commands that you use to do that. But before we look at these commands to make a file system, let's just make sure we remember the idea of partitioning a disk. Okay, so there's this command out there called fdisk, and when you go to install Linux, you can create partitions with fdisk. You can also use fdisk after the fact, like while you have a Linux system up and running, you can use fdisk. The most common situation would be is if you're adding a new hard drive to your system, then you can partition that new hard drive up with fdisk. So remember, we've got our big disk out here, and we've we've broken it up into some chunks here for different things, okay? And each of these things is a partition, and each of these partitions can have its own file system. All right, so when we're creating a file system, we're not creating it on an entire disk necessarily, but we can be creating it in just like one single partition. Now, the old command to create a file system was called makefs, MKFS, for make a file system. All right. Then what happened was the ext2 file system came along, so they had mke2fs. Then the ext3 file system came along, and instead of adding a new command, they sort of took a step back and they created this whole family of commands. makefs.ext2, makefs.ext3, makefs.vfat, and so on. And there's a whole bunch more in this family to create. So it's the makefs command followed by a dot, followed by the name of the file system that you want to create. Now there's two kinds of file systems, the Riser file system and the swap file system, that don't fall in this little family, and they have their own commands, make Riser FS and make swap. So you have to use those specific commands to make a file system of those particular types. All right, so when we go out to the Linux screen, we'll look at the fdisk command in more detail, but for now, just remember that it's used to examine or edit the partition table, and that's just a fancy way of saying you can look at the partitions on a disk, and you can also change the partitions on a disk with fdisk. Somewhere on this disk is a little space set aside, and that's the partition table, and that's what fdisk is really reading and writing when you use it. All right, so before we go out to the Linux screen, though, I just want to talk a little bit about file system overhead. All right, so when you have a file system on your computer, you're not, like I said, you're not accessing data directly. You're accessing the data on a disk through the file system. And the file system has some overhead involved with it. One of the pieces of overhead is this idea of inodes. Inodes point to the data, okay? So somewhere on your disk, okay, let me just draw out a partition here. Somewhere on this partition, all right, there is a little space set aside. And in that space are things called inodes. Okay, I'm just going to draw them as little dots. And they point out somewhere else on the disk. They give a reference saying, okay, the data that I'm representing, I'm an inode for a file, the data that I'm representing is out here on the disk. And that lets the file system know where to go out and get it. So the disk controller, the thing that's responsible for actually getting data off the disk, likes to think of the geometry of the disk in like sectors and tracks and things like that. And that inode helps it find the data based on its sector and track number and so on. Okay, now this block here where the inodes are kept, these are called superblocks. Okay, so the superblocks contain the inodes. Okay. Now the other thing is that these super blocks are actually replicated. So in case this part of the disk became corrupted, you wouldn't be able to get any of your data out here because all of these pointers would be gone. So that super block is replicated around the disk in a few different spots depending on how large that partition is that we're talking about. Okay, there could be two super blocks, there could be a lot more depending on how large that is. And so that contains some redundant information so that you can always get your data out of here even if one little piece of the disk gets corrupted that contains one of the super blocks. Okay, so that's another little bit of overhead, stuff that takes away from the actual space of storing data. Now the other thing is that inodes are fixed in number. Okay, so when you when you make a file system, okay, and you say, okay, this file system is going to be, 500 megabytes big, this partition. All right, then the number of inodes are fixed at that time. All right, and the assumption is that the file size is going to be around 2 kilobytes on average. Okay, so if all of your files were 2 kilobytes, that's the number of inodes that have been put into this super block. All right, so what are the problems that could happen here? Well, depending on your installation, 2 kilobytes might be the wrong kind of average file size. You're storing really, really tiny files, like little transactions on a database or something like that are really tiny. Okay, you're keeping track of bank transactions or something that has a very small sort of fingerprint, very small file to keep track of this information. So if your file size, say, is 1 kilobyte on average, then what's going to happen is you're going to run out of inodes, and there's going to be disk space out here that's going to be unused for data. Okay. The other alternative is that the files that you store are really large. Maybe the files you store are like 50 kilobytes on average. Then what's going to happen is you're going to have inodes in these super blocks that are unused. And so that space is wasted. So your whole disk here is going to fill up with data before you use all the inodes. And then this space in here for the extra inodes is wasted space. So on average, like I said, 2 kilobytes is a pretty good average for most day-to-day sort of tasks. But if you have a very specific thing that you're doing with the disk, like storing very large or very small files, then you can go in and alter this 2 kilobyte average so that the number of inodes matches up better and you get a more efficient use of disk space. All right, finally, the other overhead that I want to talk about here is journaling. All right, so the ext3 file system and the riser file system both have journaling capabilities. And what this means is that it keeps track of information. All right, it keeps track of the data that you're storing to disk in a better way if journaling is turned on. But there's a trade-off here, okay? And the trade-off is between data integrity, so your data is always up to date with journaling turned on, but the trade-off is transfer speed. Okay, so when journaling is turned on, you have better data integrity, but your transfers are slower. And the reason that your transfers are slower is because journaling requires a little bit of overhead so that basically things are written twice. This way that if the system went down during a disk write, then in a journaling file system, you wouldn't have anything to worry about. When you boot the computer back up, it will pick up exactly where it left off. It'll know that it was interrupted, and it will go ahead and finish that write. So you will have great data integrity. But every transfer, every write that you do to the disk actually takes like twice as long. All right. So again, this trade-off between data integrity and transfer speed depends on your installation. If you're a bank or something, you're going to want a journaling file system because you don't want to lose track of any transactions. Whereas if you're just like at a home system and you're doing some scientific computing and things that you want fast disk transfers, then you don't worry so much about data integrity. All right, so there's some ideas of file system overhead, some little bit more advanced concepts. Now let's move out to the Linux screen and look at some of these commands in action. All right, well, so let's start here by talking about a couple of the commands that we just learned at the command line. And the first one that I want to look at is the fdisk utility. And the way that you run fdisk is you give it a particular device to run on, a particular disk. And SDA here refers to my first SCSI hard drive. I only have one SCSI hard drive. If I had a second one, though, it would be called SDB. If I had IDE hard drives, they would be called HDA and HDB and so on. All right, so what I want to do is I want to look at the partition table for this particular device. But to actually look at the partition table, you don't need to go in and actually use the fdisk utility like this. What you can do is you can just use a -L option, and then what that does is it just lists out the partition table for this particular device. All right, so when I hit enter, there is the partition table for this device. And it's very disk geometry specific, right? It's talking about the number of heads and sectors and cylinders. And it's telling you for each particular partition here, like SDA1, SDA2, SDA3, it's telling you the starting and ending cylinders, the number of blocks in the partition, and so on. It's also telling you which one of those partitions is the bootable partition. So that's where my /boot directory resides, is in /SDA1. Okay, so that's one way to use fdisk with the -L command. No danger in ever doing this. You can always print out the partition table for a device with no dangers at all. But if you run fdisk like this, then you have to be a little bit more careful. So I'm going to hit enter here. It's saying M for help, so I hit M, again hit enter, and now it's giving me all these one-letter options for things that I can do to this partition. Okay, now if you screw something up as you're going along here, like you delete a partition or something like that, then you can quit without saving any of your changes. The changes that you make when you say delete a partition or add a new partition, they're not written to the partition table until you hit something like W, which is write table and exit. Okay, so be really careful if you go into fdisk like this, because you can screw up things on your disk and get rid of data by deleting partitions and adding new partitions and so on. All right, so you want to be very careful there. Remember that M gets you this help screen, and then if you ever screw something up, just use the Q option to quit without saving changes. That's what I'm going to do, even though I didn't have any changes that I made. I quit out of the program, and now I'm done with fdisk. Now, another program that you can use for partitions is a program called Parted. And this is a GNU program. It's a partition manipulation program. And I encourage you to look at this if you're going to change partitions on an existing disk, even to get familiar with this to use if you're adding a new disk to your system. Okay, you can use fdisk just as well. But if you look at the man page for fdisk, there will be words of warning in there like fdisk is fuzzy and things like that, and that makes me not want to use it to do partitioning on my system, and I would rather use the Parted program. It still seems like fdisk is embedded in the culture, and you'll see people in books and so on talk all about fdisk and how to use it, when there's other utilities out there like Parted that according to the literature, according to websites and things like that, are much more robust programs. All right, so that's the two programs I wanted to talk about for partitioning, fdisk and Parted. Now let's talk about some of these commands to make a file system. Okay, so remember that there's this whole family of commands like makefs.ext3 if you want to make an ext3 file system. So when I pull up this man page, you'll see the actual man page that comes up is make e2fs, and then there's an option to make e2fs, the -J option, and that is what creates a journaling aspect, which is really an ext3 file system. So it's a little confusing on the surface. That's why I said they sort of standardized the commands by saying makefs dot followed by the name of the file system that you want to create. Okay, and you can see here that this command make e2fs is used to create an ext2 or ext3 file system. If you called it the way that we called the man page here, makefs.ext3, then a journal is created as if the -J was specified with make e2fs. Okay, so what this is saying is that make e2fs with the -J option is just like makefs.ext3. All right. So you can see here that like I was telling you earlier, the ext3 system is a journaling file system. So that's one of the options that you can use when you're making a file system is you can add journaling capabilities. Another one is with the -i option, you can specify the number of bytes per inode. Like we were talking about out on the whiteboard, if you have large or very small files and you want the number of inodes on a particular file system to correspond to that so that you don't waste inodes or you don't lose out on disk space, you don't run out of inodes, then you can specify the bytes to inode ratio, and there's some pointers here on what you should do to actually make that happen. Okay, like the limits that you should respect. Okay, so then there's the lowercase j, which creates a journaling file system, like an ext3 file system. And then there's a whole bunch of journal options, okay? And that's sort of beyond the scope here. That's pretty detailed to go into all of these. But if you're going to create a journal, then you need to go through and look at, you know, how big the journal should be, what device the external journal should be on, and so on. All right, so there's the make file system commands that we talked about with some of the options that we talked about on the whiteboard as well. So the commands that we've looked at so far, like fdisk and makefs, they have to do with building creating the partitions on a hard drive and building the file systems on those partitions. But typically that kind of stuff is done once. It's done once when you install Linux on your system. Maybe it's done again when you add a new hard drive. If you're extending your system, extending the storage capabilities of your system, you would run fdisk and makefs again on that new hard drive. But like I said, that's basically done once. And then regularly, there's maintenance that needs to be done on the file system, and that's what I want to talk about now. So the first thing I want to do is bring up the man page for file system check. So FSCK is the way that's abbreviated, and FSCK is like makefs in that it's a whole family of commands. So if I want to do a file system check on an ext3 file system, the format is very similar to makefs. You say fscheck followed by a period, followed by the name, the type of file system that you want to check. So let's bring up the man page for this. You can see the way that the underlying command here is called e2fscheck. When you're dealing with it, when you do it on an ext3 file system, that's like adding the -j option to e2fscheck. All right, so this is the command that gets done. You can see you provide the name of the command like e2fscheck or fscheck.ext2 or ext3, and then you have to give it the device to operate on, like /dev/sda1 or something. All right, so there's a whole bunch of options here to do a file system check. A couple things before we start looking at these options. One is that to do a file system check on a particular partition, you have to unmount that partition first. You can't run file system check on a partition where there's reads and writes happening. So you have to take it offline basically by unmounting it, and then you can perform the file system check. As we page down here, there's a whole bunch of different options for the file system check. One that is important for testing things out is the -n option. This is basically like a read-only option. And so basically what happens is it'll go through the file system check, but it won't make changes to the file system. It'll tell you sort of what was found, what it determined, but it won't actually make the changes. All right. The alternative to -n would be -p, and that's automatically repair the file system without asking me any questions. Okay. So so there's two sort of extremes of what you could do with file system check. File system check is typically run every time the system boots up. All right. Down here, you'll see there's error codes or exit codes for fscheck. And these exit codes are as follows. You can read those, okay? And what happens is when the file system check is done, if you type this at the command line, when the file system check is done, one number will pop up on the screen like 13. Okay, now 13 means it's an 8, a 4, and a 1 were the exit codes that happened. Okay, so you can see these are, it's kind of like binary digits here, all right? Whatever number I put up there, like 13 or 7 or 96 or whatever, that is some sum of all these codes, and that tells you which particular codes were in, what happened. Okay, the codes are telling you exactly what happened. So a 1 code would say the file system, the errors were corrected. 2 is a little bit more. It says the file system errors were corrected, but the system also needs to be rebooted. Okay, so you can go through those. And these show up on the command line after you're finished running fscheck. One more thing I wanted to mention in relation to the file system check in particular is that there's a directory out here called lost and found, and it's a subdirectory of the root directory. Okay, lost and found is where the file system check utility will place orphaned files. Okay, so maybe there's a file on disk that's completely fine. Okay, the file's fine, but the directory that contained that file became corrupted. So because of the tree-like structure, the way that file systems are kept on the disk, this file is out there, but the file system doesn't know like what it's part of, what subdirectory it's part of. Okay, so what the file system check will do will place that file in the lost and found directory here. All right, so if something's missing, if there's some problem after a file system check, this is where you would come to find your files. Now, one complication here is that files will not be listed in this directory by name because the name information isn't there either. The name information is going to be lost, and the way that they're going to be ordered in here is by inode number. So you're just going to have to search through things to see, what files these are, and then you're going to have to put them back in place, create new directories or subdirectories or whatever in place of what got corrupted. Okay, so the lost and found directory is where you're going to find those orphaned files, for lack of a better name. Well, 2 more commands that are useful for keeping track of file system usage are the du and the df commands. Now, du, what that does is you give du a particular directory in your system, like user, source, Linux drivers or something. Okay. Now, when you run du on this particular directory, a bunch of stuff's going to scroll by on the screen. These are all the various subdirectories that it's going into and checking. And then down the left-hand side is the sizes of those directories. And then down here at the bottom is a summary for that entire directory, the entire drivers directory. It took up this much space. Okay, now this is displayed in kilobytes. If you want a nicer output, you can give it the -h command, and that gives it like a human readable output, and then it actually labels things, that whether they're kilobytes or megabytes, and then you can see at the very bottom there's 96 megabytes devoted to the user source Linux/drivers directory. Okay, so this helps you keep track of how much space is being used on your system, where the space is being used. There's various summarizing arguments to the du command that can go through and summarize this a little bit better. You can put it off into a file and then write a script to go through and check things and compare it to last week's or something like that to see if there's any, big blooming of space being used anywhere on the system. Like if you're running really low on disk space, you want to find out where that disk space went, then you can run this kind of command and sort through it either by hand or with some kind of a script to tell you, where is the space being used. Okay, then another command is the df command, and the df command works on various partitions. So for the df command, I can say something like dev slash sda2. Okay, and then it can tell me how many blocks there are, how many are used, how many are available, and then it tells me what the use percentage is. Okay, and you can do that for any partition on your system. You can also, there's options for the df command that do things like display inode usage. Okay, so if you want to check on your inode usage for that particular partition, then you can do it like this. So instead of saying how many blocks are being used, it's telling you how many inodes are being used. So the inode usage here you can see is 28%. The total usage of disk space is 65%. So my average my average size of files is larger than what they were predicting when they first made when I first made this partition. Okay, so there's the du and the df commands. That helps you keep track of information about how much space is being used in your directory hierarchy and also how much space is being used in the various partitions on your system. All right, well now what I want to do is show you how to mount and unmount file systems. I alluded to the fact that you needed to unmount a file system when you perform a file system check, but I actually haven't told you how to mount and unmount file systems yet. When you install Linux and you create all these partitions and you create the file systems on those partitions, all of those partitions are mounted automatically by Linux. And in a couple minutes, we'll look at the configuration files that keep track of that information about what gets mounted automatically when you start up your system. Okay, but first I just want to show you how to do it manually. So the way that you manually mount a device is you specify the type. So here, let's just mount my CD-ROM. Okay, so the type, file system type for CD-ROM is ISO 9660. Then you give the device name /dev/CD-ROM, and then you give the mount point where you're going to mount it in your basically in your directory hierarchy. Okay, so there's this separate device out there, right? It's a CD-ROM device. It's an ISO 9660 file system. When I hit enter here, it's going to say, okay, this is write protected. I'm mounting it read-only. This Nautilus window pops up to, so you can see the files in there. I'm just going to remove that. I just want to look at them on the command line here. Okay, so now this CD-ROM is now mounted into my directory hierarchy. So if I go over to the mount CD-ROM directory and then I give a look there, you'll see a whole bunch of files there, the same files you saw in the Nautilus window. Okay, and this is just some setup CD that came with my internet service provider to set up my DSL. Okay, so now I've mounted it. I'm in the CD-ROM directory and I'm looking around at this. Okay, now say I want to unmount my CD-ROM. All right, the command to unmount is umount. Now umount will unmount a particular device, but the device can't be busy when you're unmounting it. Okay, so if I say here, and also for the umount command to unmount a particular device, you can either give the device name like /dev/CD-ROM, or you can give the mount point. Okay, so either one's works perfectly well. They're intimately tied together when I ran this mount command. Okay, so here I'm going to just say dev CD-ROM to unmount. I'm going to hit enter here, and it says the device is busy. Remember, I said you can't unmount a busy device. Why is it busy? It's busy because I'm sitting in the /dev CD-ROM directory. So if I just went out of that directory, if I go back to like the /root directory, okay, then I try to unmount and do the exact same command I just did, okay, then it will unmount that. If I go to CD mount /CD-ROM and do a listing, nothing's there now. Okay, so when you do this mount command, basically you're tying in this device into your directory hierarchy in this particular space. So it looks in Linux like it's seamless, right? It just looks like this directory mount CD-ROM has these files in it, looks like it's right on my hard disk, right? But actually it's sitting over on the CD-ROM, and the mount command just made it look like it was part of my directory hierarchy. All right, so that's how the mount command and unmount command works. Now let's look at a couple files called etc fstab and etc mtab. So there's a file out here called etc fstab, and this stands for file system table. Okay, that's what fstab stands for. And this is a listing of the file systems that will be mounted when your system starts. Okay, so when your system boots up, these are the file systems that will be mounted. Okay, actually I don't want a CD there, I just want to print it out to the screen. Okay, so etc fstab, and now you can see which file systems will automatically mount and sort of what their device types are and so on. Okay, so first here is the slash directory, the root directory. You can see it's an ext3 file system. Then there's the /boot directory, again an ext3 file system. Anything over here that starts with none is something that's very specific to Linux, and these have nothing to do with partitions that you created. The proc directory, the dev shared memory directory, things like that are created automatically, and you don't really have any control over those. Okay, here's another one that I created. On the SDA3 partition, I created some swap space, and notice the file system type for that is swap. Notice also for dev CD-ROM, it says that the mount point for that is /mount CD-ROM. So actually, what I just showed you for mounting a CD-ROM, it can actually be done much more simply. I can just say mount /dev/CD-ROM instead of giving, and I don't have to specify a mount point because the mount point is automatically defined. Okay, so when I stick a CD into my CD drive, automatically it's going to mount at this point, mount CD-ROM. Okay. And the same goes for floppy. When I stick a floppy disk in my particular device, which is labeled FD0, then it will mount to the directory /mount/floppy. So etc tab is where all the information is kept about the file systems that are automatically mounted when the system boots up. Now, a sister file to the etc tab file is the etc mtab file, and this is actually telling you which devices are currently mounted on your system. Okay, and it tells you, whether they're read-write or whether they're read-only, things like that. Okay, so you can see the dev SDA2, which is the / file system, the root file system on my system, that's written, or that's mounted as a read-write file system, whereas dev CD-ROM is mounted as a read-only file system. Okay, and you can go through a man page on mtab, etc mtab, to see what all the various things in here mean, so that you can interpret this. But the basic thing is, this is just telling you what file systems are mounted currently on your system. All right, well, it's time to wrap up our nugget on Linux file systems. Remember that there's a whole bunch of types of file systems out there. ext2, ext3 are common file systems in Linux. The Riser file system, VFAT if you're trying to be compatible with a Microsoft Windows computer, the ISO 9660 file system for CD-ROMs, and so on. Then we started talking about how to make file systems on a disk. But first, for hard drives, you need to partition the hard drive before you make a file system on it. So that's like an extra level of detail there. And to make partitions, or to examine partitions on your system, you can use the fdisk or the parted utility. And remember that if you're ever messing with the partition table of a disk that's functioning inside of a system already, that's already been partitioned, that already has a bunch of data on it and everything else, then you need to be really careful when you play with this stuff. And just a word of caution, don't mess around with these utilities haphazardly, because you'll end up wiping out data on your system. Then we talked about the makefs command, how this is like a whole family of commands. makefs.ext2 would make a ext2 file system on a particular partition. And remember, if you're doing riser file systems or swap file systems, you need to use a separate command called makeriserfs or makeswapfs. Then there's the fscheck command. Again, a whole slew of commands here, like fscheck.ext2 to check an ext2 file system. Remember that the fscheck command will stick lost files in the /lost and found directory. df and du are pretty simple commands that check for file system usage, either at the directory hierarchy level, like you want to see how much space a particular directory is taking up on your computer, or you can check at the partition level and say how much of this one particular partition is being used, how much is still free. The mount and umount commands mount and unmount file systems, and then the fstab and mtab configuration files keep track of which file systems are mounted automatically at boot up, and then which file systems are currently mounted on your system. Well, I hope you found this nugget informative, and thanks for watching again.